The FC2310 can identify an underground cable short-circuited at both ends. The new IPROBE, which can be associated with the FC2310 receiver, makes it possible to locate loaded electrical cables. Let's see how it works. As the sum of the currents passing through a three-phase cable is zero, measurement with an encircling loop or a clamp on a meter does not make it possible to know its state of charge. Separating the phases of an MV link is dangerous because handling certain cables could cause an immediate fault. The IPROBE is the solution because it works on all cables and without the need to handle them. A bar graph and associated beeps indicate the transit of a current, 50 or 60 Hz, greater than 0.3 amps. The operator intervenes at the request of a third party to check the electrical condition of the exposed cables. As the shielding of underground cables does not allow the electrical field generated by the voltage to be measured, the IPROBE is a valuable aid. It allows all types of cables, even placed inside a duct, to measure the current flow when greater than 0.3 amps. The operator seeks to identify a healthy cable, recorded by testing all the cables visible during excavation. The performance of the FC2310 makes it possible to identify the desired cable even in the densest excavations, regardless of the cable types. When the implementation of the clamps at the ends of the cables is correct, the device injects the signals only inside the isolated cable. Different implementations are possible. Using the principle of injecting balanced current at specific frequencies into the three-phase conductors, the FC2310 provides reliable and safe information. This operating principle makes it possible to confine the signals between the two earth connections of the cable. Only the isolated one can be pre-identified. The adjacent cables supply the customers. They carry 50 or 60 Hz currents. Here, no cable can be identified. Now, to diagnose the electrical condition of the cables, the operator can connect the IPROBE to his FC2310 receiver. It can be seen in this case that the three visible cables are under voltage and under load. The isolated cable was not unearthed. The diagnosis carried out with the IPROBE made it possible to find the cable sought without risk. If the transmitter clamps are not correctly positioned, or if the isolated cable is faulty, for example, breakage of one of the three conductors or faulty accessory, the injection of current signals will be unbalanced, which will cause signals to go out in the shields or ground to nearby cable shields. Under these conditions, the identification by mistake of a live cable is possible. Let's see what this looks like on the ground. As explained previously, wrong implementation creates a way out of signals via the substation ground circuit. These signals can also flow through the cable screens. In this case, the signals can be detected in the screens of the cables neighboring the search cable, whether they are energized or not. Now the operator who has pre-identified two cables can differentiate their electrical state with the IPROBE, and thus select the one in which he will carry out the absence of voltage verification. Of course, the operator has the possibility of returning to the substation to correct the position of the injection clamps before completing his recording. As with installation faults, FC2310 signals can flow through the shields of adjacent cables. This phenomenon is generated by the impedance imbalance of the conductors of the faulty cable. Once again, the IPROBE is a valuable aid in making the correct diagnosis. Pentafamica, a secured identification.